Here is another example. Here, if you notice this expression, we have an addition, and then we have two bases with two exponents, both of which are negative. So the way to tackle this ultimately we want to do this addition here, but first we have to take care of the exponents. So we have negative exponents. That means there's a reciprocal of the base going on. This exponent does not hit this negative out here. If we wanted it to, then we would put parentheses in there, but we don't see any. So really we just have to think about what 6 to the negative 4 means, and that means 4 reciprocals of 6 being multiplied. So 4 1/6. So that's looks like this. So 4 1/6 added to well, 4 reciprocals of 6. That's I'm not going to write it all out, but it's really that. So 4 reciprocals of the base. So here this negative is, or we think of this as the opposite. Here we can think of this still as the opposite. So let's multiply these guys together. So on the top, 4 1s multiplied gives us 1. 4 6s. I did that in my hand. Oh, I didn't do that yet. 6 raised to the 4th power. 1296. Okay, so negative 1 over 1296 added to 4 these guys multiplied together, and that's just going to give me 1 over 1296. So here we have two fractions now being added, and these guys have like denominators, so I can actually add these two fractions, and we do that by applying the addition to the tops only and thinking that as a negative. So we're thinking this way. It's the best way. So we're going to apply the opposite here as a negative to the numerator, and so we have a negative 1 add a positive 1, and we get 0 over 1296. And so 0 divided by 1296, in your calculator you would see that it has a value of 0. So ultimately here, this original problem here has a value of 0. In essence, these are the same, just one of them is a negative and one of them is a positive. And for adding, they'll wipe each other out. So hopefully that helps.